lately about sending humans to live on Mars. But it's easy to say that and a lot harder to actually do it. A big part of that is because Mars isn't especially friendly to human life, or life at all. It's freezing with a super thin atmosphere that not
That's from a telescope on Earth.
But also doesn't give you much protection
Period.
from all
The larger telescopes can do that. That's what they'd see.
Terraform Mars, changing its geology and climate to be more like Earth, which is usually a subject more appropriate for sci-fi than science. But at the Planetary Science Vision 2050 workshop in early 2017, a group of scientists led by the head of NASA's Planetary Science Division suggested a way we might get started.
First off, they're going to start talking about a magnetosphere. We don't even know how to make a magnetosphere. We don't know what makes Earth's magnetosphere. We know this because every time we ignore Neptune and Uranus, and in fact their magnetosphere is off axis, and so wait, the atmosphere is outside of it. All of this shows that no, it's not made from the iron core. If Mars, if it, was because of the size, and that's why it just didn't have the magnetospheric properties because it's so small, and like the Earth, then we wouldn't have Jupiter's moons showing that no, those can have great magnetospheres even though they're so small.
And build a giant force field, a protective magnetic field for the planet. And as weird and impossible as that sounds, it's not totally science fiction.
Where have I heard this before? Oh, that's right, PBS Spacetime.
You can try to build an external magnetic shield. The easiest would be to do that in space, an orbiting field generator placed between Mars and the Sun, like a giant space umbrella. The resources and energy needed to build this is insane, but hey, we just built an atmosphere, so why not?
Yeah, said this magnetic field would replace the one Mars lost long ago, which would then let the planet build up a thicker atmosphere. Billions of years ago, Mars looked a lot like modern-day Earth, with a magnetic field, a warm atmosphere.
No. Oh, such a bad misconception. Everybody really should quit this Mars was like Earth nonsense. No. Maybe Venus was like Earth, but most likely Venus was a rogue asteroid that came in and got trapped in a magnetosphere, because magnetospheres exist, and then matter falls into them, and then they're stuck in them. That's the best and most logical solution to understanding what they are, considering it's not an iron core. So obviously that backs up everything that has, Uranus's anomalies, to be what they are. It's how did it spin this way, and why is it a little pulled out of the way? Well, they say that a comet came through. Well, then that means that it pulled it out of its magnetosphere. It pulled the properties and everything out of it that they were trying to fall back in, and eventually it either will fall back in or it will get slung out of it. We don't really know how that works, but, well, if it was going like this and centered and then something flew through it because it's gas and started spinning it this way and pulled it over, well, then the magnetosphere already existed, and clearly we fall into them, and then they either weaken or they strengthen, and whatever happens, happens. So it wasn't ever a planet. Oh, we want to talk about the riverbeds? Every time Phobos and any of these larger anomalies or rocks, asteroids, comets, anything like that that come by it, well, just as we have sprites that shoot up and lightning that shoots down, see, we have polarity points that cross, and, well, that happens there too. And, well, we've all seen what electricity does to wood and, carbon statues, things like that. It's very clear that the same patterns look like riverbeds. It's not riverbeds. It's electroburns. It's electromagnetic, reconnection points in the sun, and that little, ball of matter within those it gets burned. I think NASA did a wonderful study on the properties of the moon and how there's sunburns on it and how there's electromagnetic fields, small little bubbles that form around it to try to protect it, but mostly it's just because of the radiant environment that it is itself pushing off some of the radiant environment, and that's why the scarring on the moon, it's from, it's a sunburn from ionization pretty much. Same thing is happening here. It never was the end.
Oceans on the surface with about as much water as our Arctic Ocean. But for reasons scientists still don't fully understand, Mars lost its magnetic field about 4.2 billion years ago, and everything kind of went downhill after that. Without a magnetic field to block the charged particles streaming from the sun, aka the solar wind, much of the...
I want to point out right here, like in all my other videos, that, you know, the Earth is like a rock inside of a river, and the river goes over it, and it's got electromagnetic shielding around it, an invisible bubble that keeps any of the water from touching the rock, and then there's like little tiny dewdrops on the inside of that little bubble that keeps us safe from the river, and occasionally one of those explodes and mists, and some of that mist touches the rock. And that's how much we get of the solar wind. Mars doesn't have that bubble. It's just bloop in the river, soaking wet. So water is the Chernobyl's foot. It's literally that matter, that energy. It is just pure radiant ions that are alpha, beta, gamma, and X-ray, you know, induced, they're moved and influenced by each other, period. So it is just in the water. And, well, what happens if you want to stand on the elephant's foot? You die. That's why we don't clean it up. That's why we're putting a tomb over it. So this guy right here, that's the elephant's foot. Just like the moon is the elephant's foot. You can't touch those things. They've been in a sea of plasma being radiated before we could fathom life existing. 4.2 billion years, they just said. It's been soaking it up. So you can't touch it. It's literally a giant ionized ball of fucking radioactive decay.
The Martian atmosphere got stripped away over the course of about 500 million
Good luck.
years. Without a thick atmosphere to trap heat,
It's not what's coming down as well as what's you're on.
Unless we can find a way to bring them back, that is. Even today, 4 billion years later, and with barely
I like her
less,
enthusiasm,
Mars
though.
can lose up to a kilogram of atmosphere to space every second. We'll never
Just
get
like
back
Earth
all
is
the
losing
space
atmosphere
already,
every
but
second.
there's
Just as
still
water
gas
falls
we can
down,
go
it's
to
falling
space.
up. That's why the seas
So
aren't
there's at
rising.
least some hope of building it back up.
Sandbanks are moving, sure. Pacific Islands and the Atlantic, some sandbars have changed, but seas haven't risen.
Water trapped in the polar ice caps to rebuild about a seventh of the ancient ocean.
It's not going to work.
If we can get the climate warm enough for the ice to melt.
Because
First,
the
we have
solar
to get
winds.
the atmosphere back, and that's where the NASA team's big idea comes in. If we could block the solar wind from stripping away the atmosphere, it might start to build back up again. At first, it might sound like it involves building something the size of a planet, and that's not super practical, but the researchers proposed a way to get around that problem.
How?
By taking advantage of the fact that the solar wind is only coming from one direction.
Oh, so we're going to completely disregard cosmic background radiation, all of the radiation from Jupiter, the fact that all of the other bodies that are fucking flying around it or potentially into it are radiant. We'll just ignore everything except for all the solar energetic particles that is all light and all mass, and the consistency that space is, and, well, why not? You know, I mean, if we disregard everything, we can do anything.
So all we would need to do is block the sun. Kind of like what the moon does during an eclipse, which, yeah, would still require a huge shield, but we wouldn't have to build a giant solid thing. It would just be a magnetic field, and that might actually...
It wouldn't be a giant solid thing. It would just be a magnetic field. Again, no Apollo mission went to anywhere except for the lower thermosphere. They don't have electromagnetic fields on their crafts. This is how stupid you people are. They say it every day, and you still think we went to the moon. You still think you're goddamn wonderful creatures because America's the greatest and you were born here.
All we would have to do is figure out how to generate the field. Then it would reach out into space and do the rest.
All we gotta do is figure out how to make a magnetosphere. That's all. See? Just one. Make a magnetosphere. Step 2. Step 3. Terraforming. Right?
Specifically, the team suggested putting a field-generating device about 1 million kilometers from Mars. The
A
magnetic field would have to be
field-generating
stronger
device.
than the Earth's, which would be hard on such a large scale. But it's something we could probably figure out how to do. To understand what that would do to Mars, the researchers followed a 2-step process. First, they used computer simulations to calculate what a magnetic shield would do to the atmosphere. Then they used climate models to predict what effects those changes would have. The results suggest
We don't have tools to measure the entirety of our magnetosphere. We don't know how the entirety of our magnetosphere works. The Themis and MMS missions and all the previous missions that NASA sent up in its heliophysics departments, all of what JAXA and Roscosmos and ESA and every single nation has ever provided is all within the magnetosheath. Nothing actually goes outside of the bow shock. The entirety of the magnetosphere turns around and looks at it, measures it, anything. We can only measure certain points of the inner bands of it. So how do we use computers to simulate things that we have never been able to fathom what it is or what it looks like?
So that Mars' climate would change a bit, but that we shouldn't get our hopes up too much. Although a strong enough field would stop the solar wind, that's only one of the processes making Mars lose its atmosphere. The planet's weak gravity and molecular interactions with sunlight also contribute. In a process,
the ionosphere is very important to keep the troposphere and the stratosphere at the compositions that it are. The reason why the northern lights, while beautiful as they are incredibly deadly, is simply because, well, every single time those storms happen, it's eating up the metabolic structures of that part of the atmosphere. It's just destroying all of those molecules. And so, while it's good and it forces everything to consolidate, it's also ionizing and destroying the majority of it, sometimes bringing some of that back out with it, as you saw with the electromagnetic current points in other videos. There are always things leaving as they're coming in. Sometimes they leave at a greater rate than they come in, such as the reason why our seas aren't rising.
it's called photoionization. Atoms and molecules in the upper atmosphere can absorb energy from light and break apart. Some of those pieces end up with enough energy to break free of Mars's gravity and escape to space, which is not good if you're trying to keep the atmosphere.
What happens
and
with the
although
aurora
global
borealis
temperature
here?
would rise, this would mostly happen near the equator, which is not where the ice is. In fact, because of the way atmospheric physics works, it might even get colder at the poles than it is now. That would keep all the dry ice, which is
because ionization, as it rips apart metabolic structure, causes there to be less metabolic structure. So obviously, as it rips apart and takes the heat with it, there's going to be less heat there. Heavier radiation, heavier particles. That's why the poles are more radiant.
made up of solid carbon dioxide trapped in the polar ice caps instead of vaporizing it into gas that would thicken the atmosphere. Plus, that dry ice is sitting on top of the water ice needed to refresh the global oceans. And even if the shield was enough to thicken the atmosphere and bring back the oceans, it would take a while. Like, the researchers didn't even have an estimate of how long. So, I would...
This is the plot of Total Recall, that 80s movie with Arnold Schwarzenegger. That's literally what they just said they need to do. Oh, and create a magnetosphere with some amazing contraption we don't know what to do. But a computer says that maybe if it can figure it out, it can do it.
We just need to figure out how to make a field of the right shape and size, and get it into space. And the idea of putting something between the sun and Mars isn't that different from some proposals for dealing with climate change here on Earth. For example, some scientists have suggested that one day we might be able to launch what would basically be a giant pair of sunglasses to block some of the sun's rays and cool the planet. But before we give Mars its very own Hylian...
And that just shows how we haven't gone anywhere in our atmosphere, and that really, if we're thinking we're going to create something so big to block the sun, and yet we're not even... We have to ask Russia for rides to go to the space station they put there to replace their mirror because, well, we caught up to them once in that Apollo-Soyuz mission. Outside of that, we visited with the shuttle, and they lived there. Everybody else asked them for rides. You can't build this shit. You don't even know what the magnetosphere is. And exactly why, if you're able to understand how the polar cusps work and how electromagnetic reconnective points happen, why would you even suggest something so preposterous as to block the light when you know that potentially it's coming from behind you, from the electromagnetic reconnections from the neutral point in the tail?
Shield, there's another question that needs to be answered. Even if we can do this, should we? There's a lot we still don't know about our planetary neighbor, and we still haven't completely ruled out the possibility of alien life over there. If there is life on Mars and we totally transform the planet like this, we basically...
You don't know what a magnetosphere is, but, God, aliens, anything besides the reality that you're a fucking monkey.
Thanks for watching this episode of SciShow Space.
This is
if
pathetic.
you're interested in learning more about the hardest things about living
So
on
there it
Mars,
is, SciShow stating that we don't know what a magnetosphere is. Simple as that.